Hello, everyone. Welcome to the class of E-Plan and Electrical Control Technology. Everyone, after we complete the drawing design, we need to further check whether the circuit design is correct and whether there are problems such as short circuits and so on. Regarding these issues, E-Plan provides tools to help designers track potentials, signals, and network connections for simple simulation of electrical drawings. That is, with E-Plan, you can track the potential of any wire or cable core. You can view the status of a certain potential after it is energized. This function can help engineers find out whether there are short circuits in the project and improve the design quality of the project. Next, let's learn about potential tracking. First, let's understand the concept of potential. Potential refers to the voltage level at a specific time. The potential originates from the active device and terminates at power consumers such as transformers, frequency converters, and rectifier equipment. Next, let's see what potential tracking is. Potential tracking is a unique function of E-Plan. It helps us quickly view the extension state of potential after wires or cables are electrified. It is mostly used to check whether there is a short circuit in lines with complex grids. Next, let's take a look at the specific operation steps of potential tracking. Click Potential Tracking under the View in the menu bar, or directly click the potential tracking icon on the toolbar, and then click a wire in the potential network to be tracked. I choose L2. The wire with the same potential will become highlighted yellow. In other words, all wires from the 380-volt power supply to the motor and transformer are equipotential at 380 volts. However, since the transformer is a power consumer, the potential transfer ends here. If the wire color does not change after potential tracking is clicked, it indicates that there is something wrong with the schematic diagram. Please check the property of the corresponding component symbol. Let me introduce the third concept, signal. Signal is a subset of potentials. Signals are assigned to be connections between a set of non-connective components and are transmitted by these components. The non-connective components herein refer to terminals, plugs, and the like. That means signal transmission can be carried out between two components, including terminals and plugs. Next, let's take a look at the transmission effect of signals. Click Signal Tracking under the View in the menu bar, or directly click the signal tracking icon on the toolbar, and then click the connecting wire between any two electrical components, such as the circuit breaker and fuse. At this time, the wire turns highlighted yellow, indicating that there is signal transmission. Then, click the wire between the thermal relay and the motor. Although there is a terminal element between them, signals can still be transmitted through the terminals since they are non-connective components. Next, let's learn the concept of potential definition point. The potential definition point is used to define the connection potential of a device. It is used to specify the potential properties transmitted by one or more connections. For example, it can be used to define the line width, color, and line type of connection graphics. At the potential definition point, the potential and signal connected to the power consumer are specified together. This makes it easier to check the potential at the power consumer. Next, let's insert the potential definition point in the schematic diagram. The specific operation steps are as follows. There are also two methods for inserting the potential definition point. Click Insert Potential Definition Point in the menu bar, or directly click the icon of Insert Potential Definition Point on the toolbar, and then click the connecting wire at the L1 end. When the dialog box of Properties of Potential Definition Point pops up, enter the potential name, L1, under the potential definition, and define the properties of the wire through the potential definition point. The specific operation method is as follows. Double-click L1 Potential Definition Point to select Connect Graphics. Change the line width to 0.7 millimeters. Change the color to yellow and click OK. Insert the potential definition point L2 with the same method. Connect graphics and change the line width to 0.7 millimeters and color to green. Then insert L3. Leave the color as the default red and click OK. After the potential definition point is inserted, the wire color does not change as the generated setting needs to be refreshed before it can be displayed. The specific operation steps are as follows. Click the Update Connection button on the toolbar, and we can see that the equipotential from the three-phase power supply end to the power consumer is displayed in a highly bright color. Here's the question. The potential definition point L3 is set as red, but why is it also displayed as yellow like L1? First, let's analyze the reasons for this phenomenon. Observing the schematic diagram, we can find that since phases 1 and 3 are connected when the forward and reverse rotation circuit passes through the main contacts of two contactors, the potentials of the two phases display the same color. Therefore, to solve this problem, we need to disconnect the potential transmission of the contact points. The specific operation method is as follows. Double-click the connection point codes 1 and 2 in contactor KM2. Select Symbol Data, Function Data in the pop-up dialog box, and click Logic at the lower right corner. In the pop-up dialog box, Logic of Connection Point, delete 2 and 1 in Potential Transfers 2. That way, potentials are not transferred from the first connection point to the second connection point of the main contacts of the contactor. Similarly, the potential will not be transferred from connection point 2 to connection point 1. Then click OK. Next, perform the same for the main contacts with connection point codes of 5 and 6 in the contactor KM2. Similarly, click Update Connection in the menu bar, and the three potential definition points will be displayed in the graphic color we set before. Everyone, in this lesson, we focus on the concepts of potential and potential tracking, as well as potential definition points. Through potential tracking, we can check whether there is any problem with the schematic diagram to correct it in time. The potential, connection graphics, and line width can be defined through the potential definition point to facilitate the display of potential information in the wire. Have you got it? That's all for today. See you next time.